Generative models. Generative models in artificial intelligence. AI advanced level. Introduction. In machine learning, most models are designed to predict outcomes based on input data. However, some models go beyond prediction. They can generate entirely new data. These are called generative models. Generative models are the foundation of text generation, LLMs, image generation, music and video generation, data simulation. They power modern AI systems such as large language models, diffusion-based image generators, GAN-based systems. What are generative models? Generative models are machine learning models that learn the underlying distribution of data and generate new samples similar to the training data. In simple terms, generative model equals learns data patterns and creates new data. Example concept. Training data means model learns, distribution means generates new samples. Example. Train on images of cats means generate new cat images. Why generative models are important? Generative models are important because they create new data, simulate real-world scenarios, enable creativity in AI, improve data availability, data augmentation, power modern AI applications. Example concept. Learn patterns means generate realistic data. Generative versus discriminative models. Generative models learn data distribution, generate new samples. Discriminative models classify or predict labels. Example. Generative means create images. Discriminative means classify images. How generative models work. Generative models learn probability distributions. Example concept. P. Data means learned by model means generate new data. Workflow. Training data. Down pointing arrow. Learn patterns and structure. Down pointing arrow. Model captures distribution. Down pointing arrow. Generate new samples. Types of generative models. 1. Autoregressive models. Generate data step by step. Example. Next word prediction means sequence generation. Used in GPT models. 2. Variational autoencoders. VAEs. Encode and decode data. Example concept. Input means latent, space means reconstructed output. Used for image generation. Data compression. 3. Generative adversarial networks. GANs. Two models compete. Example concept. Generator means creates data. Discriminator means evaluates data. 4. Diffusion models. Generate data by removing noise. 4. Example concept. Noise means gradual, refinement means realistic output. 5. Flow-based models. Use invertible transformations. Example concept. Simple distribution means transformed means complex data. Latent space. Generative models often use a latent space. Example concept. Latent vector means decoded means generated output. This space captures hidden features of data. Example Python code. Conceptual. Import numpy as np. Latent underscore vector equals np. Random. randn. 1. 100. Hash hypothetical generator. Def generator. Z. Return generated data. Print. Generator. Latent underscore vector. Applications of generative models. Image generation. Art. Design. Text generation. Chatbots. Content creation. Data augmentation. Synthetic training data. Healthcare. Medical image generation. Drug discovery. Gaming and media. Characters. Environments. Advantages of generative models. Advantages include ability to create new data, useful for simulation, enhances creativity, supports data augmentation, powerful for complex tasks. Example concept. Generative models means creative AI systems. Challenges of generative models. Challenges include training complexity, high computational cost, data bias, difficulty in evaluation, risk of misuse. Generative models versus generative AI. Generative models. Technical models and algorithms. Generative AI. Applications built using generative models. Future of generative models. Future trends include multimodal generation, more efficient architectures, controllable generation, real-time generation, integration with other AI systems. Example concept. Advanced models means intelligent creative systems. Concepts learned from generative models. Understanding generative models helps learners understand. Checkmark how AI learns data distributions. Checkmark how new data is generated. Checkmark how GANs, VAEs, and diffusion models work. Checkmark how latent spaces represent data. Checkmark how modern generative AI systems are built. Simple definition. Generative models. Machine learning models that learn data distributions and generate new data similar to the training data. Final summary. Generative models are a core part of modern artificial intelligence that enable machines to create new data. They include techniques such as autoregressive models, VAEs, GANs, and diffusion models. These models power applications like text generation, image creation, and data simulation. Understanding generative models is essential for building advanced AI systems that can create, simulate, and innovate.